Okay, so today we're going to be working with 3B, which is Student Applies Mathematical Process Standards to develop and use strategies for whole number addition and subtraction computations in order to solve problems. The student is expected to use objects and pictorial models to solve word problems involving joining, separating, and comparing sets within 20 and unknowns as any of the terms in the problem. So basically today, we're just going to be focusing on two, and it's going to be word problems dealing with joining sets, and the other is going to be dealing with comparing sets. So that's what our TEK's going to be. So today, before I start, I want to go over two misconceptions that lots of students have. So the first is the misconception with the equal sign. So lots of times we just get in the motion of doing problems and we don't really think about it, and we'll just say, oh, 2 plus 4 equals, and we'll just think that equals technically means the next step in the problem, but that's not right at all. What the equal sign means is that it is the equivalent on both sides. So say our answer is 6. If we bring this down, this is also 6. So here we can see that each side of the equal sign is equivalent. So that's what that means. So the next misconception I want to go over is the commutative property of addition. Okay, so the commutative property states that, say we have 4 plus 2 is going to be equal to 2 plus 4. So what this basically means is that any way you do an addition problem, you're still going to get the same answer, and it doesn't matter which you add first. But we're going to be working with subtraction. So say we did 4 minus 2. That would not equal the same thing as 2 minus 4. So here we can see that in subtraction, you can't mix and match what you do first. It has to be the way that it's stated in the word problem. So our first problem today, we're going to be talking about comparing, and we're going to use the linear model. And when we use our linear model, we're also going to use a timeline. Okay, so here on our linear model, we can see we're going to be talking about comparing. Our word problem says that Dean ran 5 laps around the track during gym class. Jill ran 8 laps. How many more laps did Jill run than Dean? So when we look at a linear model, we can see we have our large quantity right here, and then we have our smaller quantity right here. So to get the difference, which is what our answer is asking for, we're going to look at the difference in between the two quantities. So we can see that larger equals smaller plus the distance in between, which is what we have written right here. So now, if we look at our number line, again, I'll read it one more time. Dean ran 5 laps around the track during gym class, and Jill ran 8. How many more laps did Jill run than Dean? So we know that Dean ran 5 laps, so we're going to put a dot right on 5. And then we know that Jill ran 8. So like we said, our answer is going to be the difference between the two quantities. So to get that, we're going to start at our 5, which is what Dean had, and we're going to count 1, 2, 3. So 3 should be our answer. So now if we want to check that, we can see that 8 minus 5 is equal to 3. So we know that Jill ran 3 more laps than Dean.